right, last two problems on the review. We're going to graph a log function and an exponential function. So for this one, we're graphing the log function. So as we go through this, we want to remember that logarithms are only defined when the argument, the expression inside the logarithm, is greater than 0. So if we solve that inequality, we add 1 to both sides, we get that x has to be greater than 1. So our domain is from 1 to infinity. The asymptote is actually going to be x equals 1. I'm going to remind you that when we graph y equals log of x base 3, that's the same as graphing x equals 3 to the y power. And then what we are looking at for our function f of x equals log of x minus 1 base 3 plus 2, we have shifted it 1 to the right and 2 up. Right, 1 to the right and 2 up. So if we have a table of values over here for the function y equals log of x base 3, we can get the function, the new one, by just adding 1 to all the x's and adding 2 to all the y's. So on this one, the easiest way to do it is to fill in the y column first. I think I'll go that far. If I put in -2 for y, I get 3 to the -2, which is 1/9. -1 gets me 1/3. 3 to the 0 power is 1. 3 to the 1 power is 3. 3 to the 2 power is 9. And I think we're far enough. Okay, then what we do is we're going to add 1 to all the x's because we're moving it to the right. We're going to add 2 to all the y's because we're moving it up. So for the function f of x that we have, we're going to have 1 and 1/9, which is 10/9. And adding 2 to -2, we get 0. We found our x-intercept. Well, that was convenient. I'm going to skip the 1/3, and I'm going to go to the 1. 1 plus 1 is 2. 0 plus 2 is 2. So our graph is going to go through the point 2, comma 2. 3 plus 1 is 4. 1 plus 1 is, or 1 plus 2 is 3. And remember, we're adding 2 to all the y's. 9 plus 1 is 10. 2 plus 2 is 4. So we've got 4 exact points. We were asked to do 3. Our y-intercept, let's do the asymptote. The asymptote is going to be x equals 1. So we're going to get close to 1 but never get there. That'll be our vertical asymptote. I'll go ahead and put that on the graph. All right. We took the log function that had its asymptote at the y-axis and shifted it over 1 unit to the line x equals 1. Okay, y-intercept, we don't have one. It's not crossing the y-axis. But our x-intercept is 10/9, comma 0. We found that. So I'm going to put that one on the graph. 10/9 is just barely past 1. It's really quite close to 1. What else did we have? We had 2, comma 2. So look at your table of values. We have 2, comma 2. We have 4, comma 3. We have 9, comma 10, comma 4. Yeah, 10, comma 4. All right. Look at your table of values. 10, comma 4. 10, 4. And you don't have to draw this all the way down if you don't want to. It gets extremely close to the line x equals 1 right away. And we have our logarithm function that looks like that. I'll just put an arrow on there to indicate it keeps going down closer and closer to that line x equals 1. Okay, and I think we have all the information we need. It helps if you remember what the basic graph of logarithm looks like. So if we remember this, We can shift it 1 unit to the right and 2 units up. Okay, next one. Graph the function, label at least 3 exact points. This one's an exponential. So we're going to take the basic graph, y equals 2 to the x power, and we're going to move it, that plus 3 is going to move it 3 to the left. So we're going to move it left 3. The minus 4 is going to move it down 4. And that basic exponential graph goes through the y-axis at 1, and it's going up fairly quickly. And it's got a horizontal asymptote at the x-axis, the line y equals 0. The domain of this is going to be all real numbers. The asymptote, we're taking the x-axis, shifting down 4, so we're going to go down to y equals negative 4. The y-intercept, well, I could just plug in x equals 0 and figure that out. If x is 0, y is 2 to the 0 plus 3, take away 4. That's 2 cubed, which is 8. Take away 4 is 4. So our y-intercept is 0, 4. And put that on the graph. I'm going to find out what the x-intercept is, and I'm going to find some other points as well. The x-intercept, that happens when y equals 0. So I'm going to solve the equation 2 to the x plus 3 minus 4 power equals 0. It is going to have an x-intercept because we have to cross the x-axis and get close to the line y equals negative 4. So we're going to move the 4 to the other side. Make that a little better looking 4. Move the 4 to the other side. 4 is 2 squared. We get x plus 3 equals 2. We'll subtract 3 from both sides and get x equals negative 1. So our x-intercept is negative 1, 0. All right, x-intercept here at negative 1, 0. That's a terrible looking point. Let me fix that a little bit. I'm going to figure out what happens at x equals negative 2. Well, when x is negative 2, I'm also going to figure out what happens at x equals negative 3. When x is negative 2, my y value is, let's see, 2 to the negative 2 plus 3. That's 2 to the first, which is 2. And then take away 4, we get negative 2. I put in negative 3. I have 2 to the 0 power, which is 1. And 1 take away 4, which is negative 3. Interesting. Okay. When we put in, is that right? Let me double check some of these values. Negative 3 plus 3 is 0. 2 to the 0 power is 1. 1 take away 4 is negative 3. We put in negative 2. We get 2 to the first. Take away 4, which is negative 2. So we have 2, negative 2. We have negative 3, negative 3. And then we put in negative 4. We're going to get a half. You can check the math on that, but we will get a half. We're going to get really close to the line y equals negative 4. I'm going to change that just a little bit, clean that up. And when x is 1, we're going to have 2 to the 4th power, which is 16. 16 take away 4 is 12. We're going to be off the grid. Just a little bit, but we are off the grid. Okay? And we'll go through the point 112. We get close to the line y equals negative 4. And growing really fast over here. I want to clean that up a little bit because I don't quite like that. Looks a little choppy. Still looks a little choppy, but that's going to have to do. Okay, there's our graph. That is the end of our videos for the review.